Yes, good morning and very warm welcome from Augsburg in Germany, from the Cadinas headquarter to today's webinar, How Component Manufacturers Boost Sales with Digital Twins. Yeah, very warm welcome. My name is Wolfgang Nagel and I'm today's host of this webinar. And yeah, if I look at the audience, we have small companies with us, we have medium-sized companies with us, and we have world market leaders with us. And great that you are here. Today's topic, we have more or less two parts. First of all, we will talk about the new planning behaviors of the industry. And second, we will talk about how you can use this new planning behavior as a component manufacturers to boost your sales. You don't have to take any notes. You will get the slides afterwards, and there will also be a record, a video record we will hand over to you. And yeah, you are very welcome to ask questions. So I will always have an eye on the chat. Please, we want to have really good interaction with you. We are here to serve. We are here to answer your questions. So please just type in your question into the chat, and we will then answer them. Then also stay tuned until the end. We have a great present for all of you, something Siemens and Cadinas made for you, really great present that you can start driving the digital twin. So as you see, I'm not alone here. I will start with the introduction of today's speakers. This is a webinar from Cadinas and Siemens Digital Industry Software. And yeah, today's speakers, I will introduce them now. First of all, Bernd Mussmann. Bernd is in the portfolio development at Siemens, and he takes care of the mechatronical engineering. And he is over 17 years at Siemens. He's a real expert talking about the new digital planning and also how was the history in the planning. Then also with us is Victor Braun. He is drawing with Siemens software since over 10 years, and he is at Siemens since 2015, and he is also a great expert, especially in terms of virtual commissioning with mechatronic concept designer. Then the third speaker is Jürgen Heimbach. Jürgen Heimbach, many people will know him. He is the founder and managing director of Cadinas. And yeah, he's been involved in the digital product digitalization since over 30 years. And he created a lot of innovative tools, over, I think, 300 innovations. One of the newest is the search engine 3D Find It. And last but not least is myself. I will talk a little bit about how you can really use the new planning behavior. I was Cadinas customer for many years, and now my job at Cadinas is to consult digital component manufacturers in their digital strategy. So let's start, and please just type in your questions if you have any questions, and we will answer them. So I will hand over now to Jürgen, who will start with the first part.
Yeah, Wolfgang, thanks for the great introduction. Hello, everybody. My name is Jürgen Heimbach. And before we can answer you how component manufacturer can boost their sales, we have to go a little bit deeper inside. Maybe we start in physics. In physics, you have the cause and the effect rule. So I think similar to the cause and the effect rule, there's also in marketing, we have to ask ourselves who is responsible or who will influence the purchase of a manufactured product. And a similar question I did a couple of weeks or months ago on LinkedIn. And you can already see that many people understand that components are not sold because the purchaser is asking for, give me an offer, I want to order this product. So initially, the engineer is a decision maker. The engineer is most responsible for this. So, and based on this fact, we will go on the next slide. And on the next slide, we can see on the Newton pendulum. So please animate the video, Wolfgang. Yeah. On the Newton pendulum, you can see that out of the CAD system, I go to a platform where the digital twin is hosted. I put it inside the CAD PLM system. From the CAD PLM system, it's getting in the bill of materials. From the bill of material, it automatically gets in the ERP system, enterprise resource planning. And here the purchaser in most times is buying the part. So, but you can see the pendulum is not initiated by the purchaser or the ERP. The pendulum is initiated by the digital twin coming from a Cadina's platform. And later you will also see in our current survey that there are 80 to 90% of probability that a purchase is that a component is later purchased. It's based that the engineer is influencing these purchase. So to understand what or how I can make the engineer happy, we go on the next slide, and we will see on the next slide the evolution of CAD data over the last decades. And so in the 90s, you just made an engineer happy by delivering him a 2D DXF or DWG format. So sometimes you also can make him happy by delivering a PDF. So that was in the 90s. If you went to, or if you go to the early millennium, so the engineering already started to be 3D. There you have to deliver something like a neutral format called STEP or IGES. So, but also in the first decade of the millennium, it moved. So every engineer are requesting today 3D native formats based in X or Solid Edge or SolidWorks or Creo. So, but if you're looking to the 2020s, you see that the 3D native, you make him a little bit happy, but today you need a 4D model. A 4D model is a 3D native model plus behavior plus additional information. So what we understand with a 4D model, I can show you on the next slide with a small video.
Jürgen, here's the first question, I guess, from an electrical manufacturer. His question is, yes, with his electrical components, there is no behavior. So what should he do?
So I think we will see it also on the next slide in the video. Also, of course, electrical components have behavior. And if you now animate the machine on the left side, you see a digital machine made in Mechatronics Conceptual Designer. That's a system for virtual commissioning. And there you see a mix out of mechanical components, electrical components, and also mechatronics components. These components are communicating. That means the electrical components, of course, also can control the mechanical. But a normal 3D model of a electronic or electrotechnique component cannot control a mechanical component. And what they need, of course, they need also the behavior of the mechanical components, like a PLC, and they have to give information to the mechanical components. Also, if you, for example, see a sensor, if you want to grip anything, the sensor has to tell the gripper, so now the part is right at the right location, and now you have to grip the part. So that is done by electronic components, for example. So let's go back to this machine. This machine is a 4D machine. That means an engineer, if he only engineer in 3D, in 3 dimensions, the problem is he don't understand how the machine works. Only if he start to simulate it, he understand how his machine is working and how the machine is interacting. Interacting means, for example, if you provide a gripper which is too slow or have a too slow performance, the problem is your machine is too slow and the return on invest is not high enough for your machine. So only if you understand all the processes and the interaction of the components, you really can engineer a machine in the right performance. So also later Bernd will show you more benefits of a 4D machine, of a virtual commissioning system. Before we go to Bernd, so let's see also on the right side, there is a graphic chart, and the graphic chart shows that today in the automotive industry, most of the machines or plants are already simulated or virtual commissioned. So in the mechanical industry, we also start to get this impact that we don't engineer machines only in 3D, that we also over the next years, we go to 100% 4D virtual commissioning simulation. For this, of course, we have the experts from Siemens on board, and Bernd will show you on the next slide how Siemens, together with Cardenas, is solving these requirements of the engineering of future.
Yes, exactly.
So Bernd, I think
you mentioned that perfectly. Thanks, Wolfgang, for switching over. That's great already. Let's first start with a short introduction who Siemens Digital Industry Software is. So our story starts basically in 2007 when Siemens acquired UGS. And stepwise, Siemens was increasing their software business by purchasing Vistigy and acquired Kineo and so on. And stepwise, functionalities come into our system, and we developed over the last decade with a lot of different companies. One special portfolio we acquired is Evenso Mentor, and with this portfolio we got Evenso the possibility to do electrical design, to do harnessing, to do connections, and besides in the starts from the basic CAD systems, we developed to a company which can offer a lot more than just CAD, even simulation, FEM simulations, electrical engineering tools, and so on. Good. Please switch over to the next one, Wolfgang. Right. And here I want to show you why simulation is that important, even in the engineering parts today. And there's a basic rule, and this is a Six Sigma rule of quality, or rule of 10. And this rule basically says that if I find a failure in an early engineering phase, the cost of failure erosion or of correct the failure is quite low. Yeah, and in the next steps, the costs of failures are getting much higher by the factor of 10. So if I find a failure in the commissioning phase, the cost of correction are by 100 already. And even if I need to wipe out the failure through operation, the costs are even higher. So the conclusion is that I have to increase the quality of my engineering as early as possible. And this I can do by finding failures in my engineering quite early. So, and this helps to reduce the costs of my engineering, and even so by designing my products. Good. Please switch over to the next one, Wolfgang. Yeah, and this is a slide which shows on which levels we can do simulation, and I like the question we had in the beginning. If electrical components have a behavior, even so, and if you see a full kind of virtual commissioning or simulation consists continuously out of 3 parts. I have my mechanical or physical simulation and the physical behavior of my component, of my machine, or my plant, or anything like that. And then even so, I have a part of electrical behavior, because all these components I simulate are mechatronic components. They do not exist only of a mechanical or physical part. They've even so electronical parts, like a drive for controlling a motor. This drive has a signal behavior, and this kind of behavior can model in a behavior model and add it to my simulation, so that I stepwise get a bigger machine, a completer machine to simulate. And of course, the third component and continuously need is a controller system, a PLC system, basically, which I do need to finally do a complete simulation of a machine, for example. And finally, what I need is a single point of truth where I can store my data, where I put my digital twin in, and that is commonly a PLM system. And this is not an invention by Siemens. This is a natural thing, I would say, how simulation for virtual commissioning, for example, has to be structured. Good. Please.
We have one question, I guess, from a mechanical engineering company. They ask if I choose now to work in this kind of way, do I have to switch my completely engineering department, or do you always just start with one seat? How can I introduce this kind of planning into my very sophisticated engineering department?
Sure. So you don't have to wipe out everything and start from the scratch new. No, you don't have to do that at all. So start with a seat, for example, for mechatronic engineering, like the mechatronics concept designer. It depends a little bit on what kind of task you want to fulfill. And then you can start with a simple concept simulation already. And you can stepwise then through the engineering phase add some components and modeling steps as you need it. But you can really start with a simple step already. You shouldn't have to do all by big one step. This would be too much, I would say.
And maybe a second question that fits to the first question. So what are really the benefits for the mechanical engineering company? Because he writes here, it looks like a lot of effort into introducing all those new software, training and so on. So what are really the benefits?
No, we certainly have references, and we can tell you, if you start working in a mechatronic way, I would say, to execute virtual commissioning at the end, you certainly can save time through the engineering process. You have to consider that you really find failures and wipe them out through the engineering phase. Everybody of us has been on site for commissioning a machine or something like that. So that if you start building up the machine and if you want to start commissioning, there happen some issues. For example, a drive is designed too small so that the machine cannot move. Yeah, and that of course will delay the commissioning. Yeah, and if you find such simple errors in an early stage of engineering, you can prevent you can prevent these issues on site, and you certainly save up to 30% time through the total engineering process. Even the real commissioning phase will be much faster than 30%. We have a couple of references where we have executed that, and yeah, that's really a good thing. And this is finally a big benefit. Another issue, even through these times, you can prepare with virtual commissioning your commissioning from your office desk. Yeah? That you can see how the behavior of the machine is, and the commission engineers can prepare from the office seat and start with a better knowledge of the machine into the real commissioning.
Thank you. And at the end of the meeting, we have also a present, as I said, so you will have the opportunity to get a free trial and to really introduce it into your company.
Good.
Thank you, Bernd. You have to add something, Bernd?
No, that's fine. I just wanted to start over with the next slide. So I'm right excited to present, as you know. Oh, my time is over now, and Victor starts over, right?
Yes, that's true. Thank you, Bernd, for introducing the different levels of simulation, as well as, of course, talking about the behavior models.
And it's great to hear some real example which you can show us, and going a little bit deeper into details. It's really great. Thanks for that, Victor.
Exactly. So this will be my task, showing you guys a couple of examples and some more deeper insight maybe into this mechatronic design approach that we are following. So here, as we saw in the earlier slide, we had different levels of simulation and different levels of tasks. But here we wanted to show you a very simple, or at least that seems to be simple, engineering task at hand for a production machine level. So here we see only a small door on the left side from a machine. But when we take a closer look on this functionality of being a door to provide access to the machine, we can see that we need a couple of components realizing this function. And when we see on the right, or we take a look on the right side, we can see that we would need to have a limit switch, for example, to detect if the door is opened or closed. But we would need to have some I/O signals that are connected to the PLC, and the PLC needs to have some kind of software that also detects if the door is opened or closed, and maybe stops the machine if the door is opened by accident. So we have a couple of different domains that are involved, and this is the most important part here. So the solutions are not always mechanical. So, and if we take that into consideration, we detect that in the early phases when we design a machine, we need to involve mechanical, electrical, automation departments, maybe even fluidic departments if we have some pneumatic or hydraulic applications as well. So the tasks are getting quite complex and interconnected, as we would call it. And if we look at the data, going into the next slide, please, we can see that we have very much information that is spread throughout these processes. So if we want to do some collaborative engineering, we need to have some kind of multi-domain data. So we need to combine the data, for example, that concerns the PLC code, or for example, that is designed to be for the electrical definition of the components in electrical CAD systems, for example. Of course, we do have 3D CAD data that we are working with for many years now. But nowadays we also have kinematics and maybe even mechanical connections. As we talked earlier, we have also electrical behavior and mechanical behavior that is relevant nowadays for this collaborative engineering approach. And this is what we want to approach in Siemens. So as we saw earlier, we have this different levels of simulation, for example, production lines or production machine level, or even the level of a component in detail in the component physics. We also have electrical behavior that's relevant for us. We have the control system, etc., and everything needs to be somehow interconnected and provided by component suppliers as well nowadays. So let's take an example on the data that can be provided through the systems. Going to the next slide, we will see, for example, here we took a deeper look into the kinematic definition of an object. So in this video, let's see if it plays. I hope it plays for you guys. For me, it's a little bit not as fluid, I would say, but I have it as a backup here as well. I hope in the recording it's responding a bit better. So here, for example, our task is to have a gripper installed into our machine. And as we can see here, we are in the NX design environment, and we can browse through the Cadenas library in this case, and of course select our gripper. In this case, it's a simple shrunk gripper. And here we place the object directly in this dialog. We can, of course, define the parameters, configure our component, similar as I would do it in Cadenas part solutions, for example. But here it's completely integrated in NX. I can use the default NX functionality here to place my component on the right position. So have some assembly constraints defined directly for this component. This is I would say, some default functionality that there is. But the interesting part about this component that we just added is it's actually multiphysics. So it includes some kind of behavior in addition to its 3D representation. So in this case, when we switch to Mechatronics Concept Designer, we will see that we have the physics already defined. So the gripper in this case has the functionality that it has 2 axes that grip the components. And this is something that is provided directly in the component via Cadenas. Going to the next video, this is another example from the multidiscipline of engineering. So here the task is to define the electrical and cabinet design for a component or for a machine. And here we are also in NX, but in this scenario, we are in the automation and electrical design department. And here the task is to add components to the electrical cabinet as well as to the electrical schematics. And on the left side, we see the function aspect navigator. This is more like the electrical structure of the machine. And we can switch to the feed-in department or feed-in area here. And we can see, okay, here we need a new component. We might already have a schematics for the component, but we are not having the specific component selected yet. This is a common, I would say, common workflow for electrical design, to have a placeholder at the beginning and then specify the component further in a later stage. And here we can also use the web browser here, for example, and directly browse to the part community. In this case, we are more interested in the combination of 3D data as well as the electrical design data, because we want to have electrical information added to the components as well. In this case, we need a circuit breaker and some solution for overcurrent. So we go to the Siemens department in this case, or the Siemens area, and select a power connector. Here we see directly of course, the 3D preview, as we are already knowing or already using in 3D CAD design. But here we are more focused in this task on the combination of CAD and electrical design. So we select a component that fits our electrical needs. As you can see here, of course, we have our parameterization for the component, and also the electrical parameters. I can see I have the 3D design on the right side. Switching to the 2D design, we have, of course, the layout of the components as well. But the important part here is when we generate this component in the next clicks, we actually generate not only the mechanical representation of it, but also the electrical. So, and for the electrical representation, we need classifications, for example, via E-class, and this is provided with a component. So here I can add this component to my customer library that I'm using currently, and it's automatically specified and classified via electrical parameterization. So here on the NX reuse library, I can just refresh my part, and we can see, okay, the component is added. And this is the electrical and mechanical representation. This is the most important part here. So for my electrical structure, I can now select this this component here, add it to my electrical design, and here I just can drag and drop the component to my electrical design as well as to my schematic design. So, and place it, of course, in my cabinet in this case. So these two small examples we wanted to show you. For example, the first one was the 3D data included with the mechanical, kinematic information, as well as the behavior from the gripper, for example. And the second example was the 3D data included with the electrical design, which is, of course, also included in the multi-domain data that we want to provide to our customers. Going to the next slide, we can see it in a different view. So we have, of course, our different libraries, and the important part is that we need this multi-domain data here. So depending on what level you are working on, you might need some information about the component that includes, for example, simulation data for virtual commissioning, or electrical data for cabinet design or schematics design, but also, of course, 3D data, maybe even the kinematics just for internal simulation of the timings of the machines, etc. So this is something we want to provide, and we are working with Cardenas together to have different integrations and, of course, different possibilities for our customers to work with this multi-domain tools. So, and as a small example for Siemens components, if you go to the next slide, Bernd, did you want to talk about the different Siemens components that we offer here?
I can do. Thank you for that, Victor. And I really like this nice examples you brought over because it really shows that our NX platform is not only anymore a CAD platform, it's really a platform for mechatronic engineering, so that I can do the mechanic design, that I can do mechatronic engineering by placing the kinematics for sensors and actors, and even so I can do the electrical engineering. So basically all I need for mechanical engineers or for machine builders, I would say. Yeah, and even mechanical and electrical engineers are so far. Good. One point to the libraries we have actually in together with Cardenas. So right now there are roughly 50,000 products of Siemens already in this library and accessible for our customers. You can download it through part community, or you can get your Cadines app and download it there. And great, Wolfgang, that you switch over to the library here, that we can have a short glance. Maybe you can talk even so a little bit on that, Wolfgang.
Yeah, no problem. This is here the public part community catalog of Siemens, and we are now here on a single product here. But as you can see, at the very highest level, you will have very different. We'll switch here to English. So you also see the catalog is in multi-language available, and you can click through this digital catalog and find the component you are looking for. You of course can also make a search by order number, by really the name of the product. Then you can find your part. You have all the overview about the attributes. You have different kind of filters here, so you can filter by names, by attributes. For example, you're really looking here for a certain diameter or for a certain other data. So you can really find here the right product, and then you can download here in the format you are looking for, especially not only a CAD format, it's really now you need a format with all the metadata also.
Right. This catalog is free accessible as far as I know. Is that right?
Yeah, it's free available for the users. So the users are in the best position here. They get best planning that data for €0.
That's great to hear. So sorry, this question has been pre-discussed, Wolfgang. So sorry for just asking this one. Good. Yeah. In general, I would say there are over 700 manufacturers already in your catalog. Is it, Wolfgang?
Yeah, correct. Growing and growing. Of course, there is a big. We have to be honest. There is a big disbalance. Many of those catalogs are not sufficient at the moment. So we have seen that there are new requirements, and many of them have to be to get better to really fit these new requirements. But in general, we have over 700 manufacturer catalogs.
All right, great. So maybe you take over, Wolfgang, and going to the next slides.
Yeah, thank you, Bernd and Victor. Really very impressive what is going on in the planning market. And now the big question is, so summarizing the last slides, we talked about the new planning behavior. We saw, if we look back in the slides, how Siemens software can support this new planning behavior, which advantages, especially talking about costs, this new kind of planning has. And this new planning behavior has been speeded up by COVID. So many people say COVID is a pause button, but in real, COVID is a fast forward button. So all this planning behavior was what was maybe before COVID was, so in 2 or 3 years, is now the very present. And what does this mean for you as a manufacturer of components? It means that you need to offer data that really is attractive to your engineer. And maybe you know this quote from Germany. It says, the bait has to be attractive to the fish and not the fisherman. If you are a fisherman, then you know that the bait is not very tasteful. So this is exactly the same with planning data. So before this digital transformation in this new planning behavior, it was sufficient just to deliver mechanical formats, such as maybe it was even sufficient to deliver step data. But now we have really much more formats, much more data that is required. Talking about simulation, especially today, or electrical behavior. If you are also in the architecture market, there are many formats. And yeah, this is the thing you need to deliver to the market. If you don't do that, I always say this is like like you are an ice cream shop and you just offer one taste. Maybe you just taste yogurt ice. I personally don't like yogurt ice. And if somebody enters the shop who likes to have strawberry or lemon and you don't offer it, we will all can expect if he is going to come back. And yeah, if you just, now we have a comparison. If you deliver step data, we also call this step data digital zombie. And on the right side, we have the digital twin, and the digital twin is the aim, because the digital twin has the aim and the power to really, satisfy all the needs on the market. And if you just deliver step data and maybe some data sheets, you see here the effort of 80 minutes. He has, your engineer, your customer has to do it on his own. 80 minutes. This is, if we stay at the example with the ice cream shop, it would be like you just hand him over the milk and maybe some fruits, and then you say him, yeah, make your ice on your own. So this is something that was possible in the past, but now all those companies, especially through COVID, they have to look at the costs, and they also have to look at the internal costs. And if you can help them to save the time from 80 minutes in this example to 4 minutes, to save over an hour internal costs, you will be able first to sell your component, and second, you will be also able to get a better price for your product, because you can argue your price much better because you save so much time to your customer. So yeah, just to think about it. What would you do?
Exactly. May I add one thing on that side?
Of course. Yeah.
Yeah. Even so, you support your engineers in reducing the organizational part. Yeah, your engineers can really do engineering work, to be creative on engineering, what they really like to do, and not organizing everything in the right way and doing administrative things. Yeah, this commonly engineers don't like to do, and this helps even to create better products, I would say. This is even a big part which we shouldn't prevent to say.
Thank you. Yeah, very good. And yeah, just an example from my past. I was Cadina's customer on my own, and I always was faced with commercial buyers who said, Mr. Nagel, you have to get cheaper and cheaper for your components. Then I said, I won't get cheaper because I save you so much time internally. And then, of course, he got a discount of 1.5%. And then I heard from another company, they had to give him 20% discount because he did not give him those kind of data. So this is something really helpful, also negotiating your price. We have here also one question from Dan Mills-Bell. He asked the question, if you now deliver your data in all that kind of way and all, maybe give all those digital twin data to the market, if there is any possibility to protect your data, your manufacturing data. And thank you, very good question, a very often asked question. So of course, we don't deliver here any manufacturing data. So these are reduced level of details. The technical data, of course, is very precise, because all the simulation is going on, all the calculation that is going on has to be very precise. But the geometry is really reduced level of detail, so there is no way that they can't really copy your part.
Yeah, and let me also add something. You also can protect your behavior of the data. So there are systems like the functional mockup interface or functional mockup unit. There you can, like you know from software and DLL, you also can hide your knowledge inside a DLL system. So all your behavior is also protected and can be, of course, protected.
Thank you for adding this, Jürgen. It's very important, especially nowadays, if you offer data to the market, that it's really protected. And now, as I said, COVID really changed the market completely. We also see this very often if we talk about social distancing. And yeah, it's what many people say, or what doctors say is high risk, of course, is going into nightclubs and indoor parties. But what is also very high risk is going to visit fairs and trade shows or customer visits. So this is also why it is forbidden at the moment. And the question you have to ask yourself, how will you now reach out to your customers? How can you make good interaction and in the end sell your products? And this is very good possible with digital tools or visibility in the NX library or in the Cadinas library that are available in public. And the great thing is really, if any engineer now downloads this component, you will get a notification who downloaded it, and you can now contact him. And what very interesting, on the next slide, we see here, this is the statistics on the download over the last year. And of course, COVID also influenced our raising downloads. But what happened after the first lockdown is very interesting, that we really had a maximum speed up in the downloads. And as you see here, with 80 million downloads per month, that the digital planning is more and more, is the daily business. So all that data sheets and so on, all that print catalogs are still good things. It's always the combination of online and offline tools, but we see here very direct that the engineers go into more digital planning, and this is something you can use. Many of our customers used it to increase their revenue, their downloads, or maybe even decrease their efforts in creating data, decrease the time, how long their customers have to wait for an offer. For example, in this case, from 2 days to 5 minutes. And in a digital market, it's not about, first of all, it's a competition of data quality, and then it's always a competition of who is the fastest. How fast can you deliver? Just think about yourself. If you order something at Amazon and you don't get a notification that the order is done within 5 minutes, then you get kind of nervous. And this B2C attitude we all have now in us, that if you don't get a notification without 5 minutes, this also happens on the market. So if your customer does not get his offer or his product immediately, he gets kind of nervous because he is so much influenced by his Amazon and so on, all the other stuff. So in the end, we want to support you to get into this process, to get started. And this is why Siemens and us, we created a nice package for you. So we will help you, no matter if you are a mechanical engineering company or a component manufacturer. You get completely for free an individual workshop with Siemens and Cadinas. If you are a component manufacturer, we will model a digital twin with all the behavior information and all the geometry information. And also, maybe Bernd, you can explain what Siemens is offering here.
Yes, I slightly can do. Actually, we will help you to get a test installation for the mechatronics concept designer, and even so that you have a guided introduction into that working process with mechatronic engineering, of course.
Great. So if you're interested, just write an email with Digitaler Zwilling Workshop or Digital Twin Workshop, however, to this email address, my email address, or from Victor, his email address. And yeah, the offer is valid until the 30th of April. I think the 1st of May is the official day of work here in Germany. So if you want to get started until there, it's a great opportunity. And yeah, so we have 10 minutes left. We have 10 minutes left. So if you have any questions, you can now type them into the chat and we will answer them.
So Wolfgang, always a question is, for example, that can I also get additionally to this webinar, can I get some videos that I can show my management how it works? So I think we also can share, of course, the videos what Victor, for example, showed that you can maybe show to your management what is a 4D engineering, what is the future of engineering.
Yeah, we will share the slides and also the links to the videos. So we know from experience that there is often the case that you will like to try it, but you need to convince your boss in your department. So we will give you good data to introduce it to your department. And this is also why we created this offer. There is nothing to lose. We can really make it very customize it to your needs. And yeah.
Jürgen, Wolfgang, maybe one of you can answer that. Actually, how many percentage are today coming from the library within engineering? Can you say that?
So I can show. Like yeah, sorry for interrupting you. So that's a good question. So we have up to some customers who are using the digital twin data, and I have some examples I can also maybe later add to these slides that everybody can see. We analyzed already that we have customers who are using 85% of standard parts of manufacturer components for their engineering. And I think that's a very important impact also for COVID, that I should engineer everything myself. So why I have to invent the wheel again and again? If, for example, companies like Schank or Festo or Zimmer already delivering this kind of products. So for me, it's a faster engineering and it's a more accurate engineering. And of course, it's also a very good automation. And for COVID, automation is very, very important because you have to engineer machines without lesser and lesser people, that they cannot get infected if there's coming a pandemic again and again, or you have to lock down. You still have to produce your products. So to answer your question in short, 85–90% is nothing unusual.
All right, sounds good.
Okay, great. So here is another question: how much effort is it really now to create digital twin data or step data to digital twin data? And yeah, we can really start small here start with your top selling products, or maybe start with the products that you don't sell at the moment and boost your sales with these formats. And yeah, the question always is, what is the price if you don't do it? Because the lost opportunity costs, if you really just hand them over, not the ice cream, just the milk and the flavor, do it on your own. We know, and Bernd also said, the engineering departments are very, very busy and they don't get paid to make the work you should do as a manufacturer, as a component manufacturer. So we also offer good packages now during COVID times that everybody can start somewhere.
Yeah, and Wolfgang, let me add to your metaphor about the ice cream. So if you have the right ice cream machine, so the effort is not too high to make a good ice cream.
Now I want to have ice cream. Okay, but yeah, COVID. We don't wanna talk about COVID. No, I think everybody's fed up with it. But the great thing is you can use it. You can get a winner out of this situation, because any time of crisis leads that you can really win great market shares, but you can also lose great market shares. This is only possible in a crisis situation. In a not crisis situation, the market is very settled, but in a crisis situation, you can really win great market shares.
Maybe a small addition from our side at Siemens as well here. So we are experiencing the exact same behavior with COVID as well. So for example, we were distributing virtual commissioning implementations and software that provides virtual commissioning capabilities, so that you can postpone your commissioning phase, or at least do your commissioning phase in the office or even in the home office, which was not possible before. Here with COVID, we experienced that a lot of demand is now being on exact the same this application, so that we are able to do virtual commissioning earlier, maybe in the design phases, as Bernd showed with the slide in the rule of 10, for example. So virtual commissioning is one example where we see that this shifts in the early phase, and of course in a safer environment like home offices. And for that, of course, we need to provide behavior models maybe, and kinematic information, etc. So this is also a catalyst for that.
Okay, then I have here a question. Maybe a mechanical engineer asks, he does not has any Siemens software yet. He has another software, so can he also use this package now to start?
Yes, I think there was a similar question before, but to elaborate on that, of course, we can start small. For example, if you're using a different CAD system other than NX, you can still, of course, use Mechatronics Concept Designer, for example, and Mechatronics Concept Designer enables also you to hand over data from other CAD systems and, for example, do virtual commissioning in this environment. So yeah, it's possible.
Okay, great. So here are again all the contact data. If you are interested, just write us an email or contact us on LinkedIn. We are all on LinkedIn, and yeah, we will help you to find the right solution for you. Okay, any questions left? If not, we will wrap it up. We are 2 minutes before 11, so thank you for participating to today's webinar. And yeah, you can choose our offer. Maybe you know my quote, digitalization is not the future, it is the present. So you should use the current situation. Maybe you have a little bit more time in your engineering department to try something new, because if you are busy after the crisis, then you won't have the chance maybe to introduce something new and use the time you have right now. So thank you to Jürgen, to Victor, and to Bernd for speaking and showing us so much great examples and details.
Yeah, that was a pleasure today. Thank you very much for organizing everything, Wolfgang, and looking forward to meet you on one of our next webinars.
Thank you and have a nice day. Take care. Stay in good health. Bye-bye.